Hello everyone. In this video, we will solve questions of activity 11.8. Question number 2. Let x denote the number of radioactive particles passing through a counter in 1 millisecond time interval. The probability that the number of particles passing will not be counted is 0.01. Assume that x follows a Poisson distribution with parameter lambda is equal to 3. Find the probability that the number of particles counted during a specific time interval is 3. So here x, random variable x, is representing the number of radioactive particles passing through a counter in 1 millisecond time interval. Okay, and the probability that the number of particles will not be counted is 0.01. So we know that probability of success here will be that the number of particles being counted. So P will be probability number of particles passing will be counted. Okay, so P will be equal to 1 minus 0.01. Okay, now here we can see that lambda is given as 3. So lambda is 3. So lambda represents the average number of particles passing through a counter in 1 millisecond time interval. Now let us assume that y is another random variable. Okay, so since here we have to find out the probability that number of particles counted during a specific time interval. So let us suppose y is another random variable which represents the number of particles counted during a specific time interval. Now we have to find the average lambda dash, which is representing the average number of particles being counted during 1 millisecond. Okay, so we know that lambda dash will be equal to lambda times P. Okay, so lambda, which is representing the average number of particles which are passing through a counter. Okay, so lambda is given as 3 here. Lambda is 3. So 3, and probability of success is the probability that the particles are being counted. Okay, so P is equal to 0.99 here. Okay, so 0.99 proportion of the particle which are passing are being counted. Okay, so lambda dash will be 3 multiplied by 0.99, which is equal to 2.97. Okay, so lambda dash is representing that 2.97 number of particles are being counted during a 1 millisecond time interval. Okay, now we can find the probability that the number of particles being counted during our time interval is 3. So y is equal to 3. This probability we have to find. So it will be equal to e to the power minus lambda dash to the power x lambda dash to the power y divided by y factorial. Okay, so e to the power minus 2.97 to the power 3 divided by 3 factorial. Okay, so this is our answer. Now from the given options we can see that option number B matches with our with the correct answer. So option number B is correct here.